This is the pre-lab for the Inference for Regression lab, and this is the formula version. So we're just going to start the way that we always do, setting up the packages that we need. So I've got library mosaic, and then we're going to load in that same example data that I'm always using. So it's from the General Social Survey. And in this lab, we're going to be talking about regression, which we've talked about before as a descriptive technique. And now we're going to move on and we're going to use it more as an inferential technique. So we're going to be using a distributional approximation, the t distribution, instead of doing some kind of simulation, but we're going to be doing some confidence intervals and hypothesis tests. And I'd like us to consider the same relationship that we did in the lab 3. We're going to try and predict the highest year of school someone completed based on the highest year of school their spouse completed. So that's our explanatory variable, the spouse's education, and then the response variable is the number of years of education that an individual completed. So the first thing we should do is a visualization of that relationship. So I'd encourage you to pause the video and see if you can figure out how to do that visualization. All right, I'm going to do it. So we need to start with GF underscore, and then we need the right kind of visualization. And in this case, it's a point. And then we need to think about the y tilde x format. So the y is going to be our response variable, which in this case is highest year of school completed, and then tilde highest year school completed spouse. And then we need comma data equal to GSS. And so if I control enter here, I'm going to get a nice scatter plot which shows the relationship between highest year of school completed and the highest year of school completed spouse. It's that maybe moderate positive linear relationship. And now we're going to try to compute a model and find the regression line. So I would encourage you to see if you can figure out how to run that linear model to create a regression line. So the next thing that we need to do if we're going to do inference for regression is we need to compute a model. So let's start using the lm command. And the first thing that we put in is our response variable, which is highest year of school completed. And then we're going to use a tilde, and then we put our explanatory variable, which is highest year school completed spouse, comma data equals, and then the name of our data set, which is GSS. So this line of code is seeming kind of long, but hopefully you can still read it. I'm going to make a linear model, and I've got my y, and then I've got my tilde and my x. And if I just control enter here, I'll get some output in my console. Maybe I can scoot this over so that we can see it more easily, and control enter again. So there's my output. But for this lab, when we're doing inference, we're actually going to need a little bit more information. So we should give this model object a name so that we can use it later. I'm pretty uncreative with my model names. I usually just call them something like M1. And then I use that assignment operator from R, which is the less than sign and the dash. And I'll just put that there. And maybe I'll put a line break in here so it's a little bit easier to see. So now I'm saying M1 gets the linear model, all this stuff. And if I control enter, nothing happens in my console. But if I scroll over here, now I have something in my environment. It's not very easy to look at this object here. So you either want to look at the output in your console, or maybe you want to run summary of M1 and then control enter there. So again, I think I need to make my window a little bit bigger so I can really look at this, and then I'll run that code again. So I've got my call, which is just kind of reminding me what my code was. I've got some information about my residuals. You can just ignore that. Most of the important stuff is in this section called coefficients, and the most important column is this column that says estimate. So that's my estimate for my intercept and my estimate for my slope. And if I wanted to, I could use LaTeX to write out the equation of that line. So here is my syntax /hat y, because it's the prediction. And then I've got my intercept plus my slope times my explanatory variable. So that is the equation of the line. If I was asked to find the regression line, this is what I'm looking for. And then we should just review how you interpret that slope value, the 0.59. I usually say for a 1 unit increase in the explanatory variable, highest year of school completed by a spouse, we would expect to see a 0.59 unit, and then it'll either be an increase or a decrease. It's an increase in this case because our coefficient is positive. Increase in the response variable, which is the highest year of school the person completed. So, and I should put in the units. I think the units are years. So for a 1 year increase in the highest year of school completed by a spouse, we would expect to see a 0.59 year increase in the highest year of school the person completed. So that would be my interpretation for the slope coefficient.